Okay, now let's get ready to do some work. This week is going to kind of get you started with why do you even need to learn statistics? What can you use it for? And then how to do some graphical, some visual overviews of data where you're not looking at a huge data set. Now, what I do in these previews is just kind of overview what you need to read in the book, right? And then don't forget the videos that I have posted that actually shows you how to create some of these things. All right, so let's get this party started. So statistics is so important, especially in your guys' field, to be able to study, various applications in business. And you're going to learn descriptive and inferential. Descriptive, what it sounds for, is you just describe the data. Typically, this is the visual stuff that you're going to learn this week with the different types of charts, but then it's also where you can summarize data, and that'll be next week. Inferential statistics is more, let's dig a little bit deeper and answer some questions about our data, like why is this product not selling, such as that. And then understand difference between population versus a sample, meaning the population's what you want to learn about, but typically you can only go out and ask so many people, and then also identify variable types. So there's certainly a lot of statistics in many different fields in business. And in fact, a lot of times students will say, yeah, but there'll be some statistician that'll do this for me. But don't you want to be able to understand how to read the reports that they give you? Certainly in your schooling, as you continue, you will be given journals that you'll be asked to read and to be able to understand all the statistical terminology. So our whole deal is we want to be able to go out, collect some data, analyze it, interpret it, and come back and tell our boss or whoever, the company, what we found. As I mentioned, we normally start by just describing our data, and then we try to make decisions based off of the data. When we get data, we're interested in an entire population. And if I could gather data from the entire population, that's a census, but typically I cannot. So I want to know how many UTSA students have children. Well, I probably can't get every single person in contact with them, every single UTSA student, and some may not even answer. So what I do is I get a sample, and I might go from building to building and ask, or set a poll up and ask students, do you have children? Once we get this data, I need to understand that it's variable. Just like you remember in algebra, what's a variable? Something that changes, can take on different values. Even your different majors, concentrations, those are variables. I can come up with an actual measurement of data, and that's what I want to get to a point to where I have a single characteristic that I'm studying. Again, children at home. So when we study an entire population, we're looking at a parameter. And there's many different types of parameters, as you're going to see later. We're going to look at a population mean, the average, a population standard deviation, a population variance, a population proportion. But all of these are based on the population, and as you can see, represented with Greek letters. But the statistic is where we go out and get our sample. So that's kind of our study there, to get our sample. And this is represented with the Roman letters, so I might want the sample mean that tells me about my population mean, and so on. And then you're going to look at the levels of data measurement. This is important to understand if you have quantitative, numerical data, or qualitative, categorical data. And each one of these, of course, has their own definitions that you need to understand. Nominal, male, female, something like that. The religion. Then the next one, ordinal. So nominal is categorical, put things in categories. Ordinal is also categorical qualitative data, but now we have some kind of ranking. Probably the easiest thing to think of is where you rank things on a scale. When you fill out my evaluation, hey, that's what you're doing. Okay, so they're collecting ordinal data. Interval data says it's a measurement. The distance between the attribute does have meaning. So, for example, if we're talking about the differences in temperature, one thing that a lot of times will state, and this confuses students sometimes, is that 0 doesn't mean something does not exist, where you're going to see next ratio, that's what it means. And it's hard to come up with a lot of examples like a 0 Fahrenheit temperature. Does that mean the temperature does not exist? Well, no. Okay, so that'd be interval. The females, probably something you could think of right away. There is an actual dress size of 0, right? Does that mean there's no material? So that's what we mean by the non-existent of a 0. Then ratio, I think of ratio being a math person. I think of fractions. I think of, something as half of another. To me, that's the easier way to think about it. You make twice as much money as I do. So that's probably the easier way, but this one does have the true 0, meaning if you have money being ratio data, if you have 0, you don't have anything. It doesn't exist. And there's kind of an overview of looking at the qualitative, the quantitative. I think the qualitative is pretty easy because is it in categories? Does order matter? That's pretty much it. The quantitative data, a lot of times students have trouble with the difference between interval and ratio, and the majority of your quantitative data is ratio. All right, and then you move on to where you're going to look at different types of charts and graphs, a time series, looking at something over time, a dot plot where each one of these dots represents a data value, stem and leaf, which I'll show you here in a second, which is kind of better for small data sets. And then scatter plot, this is very important because this really helps me see a relationship between two variables. And what I'm looking for is to try to figure out of a quantitative data set, the shape, because even here I can kind of see the shape of my distribution. So I very much, anytime I have quantitative data, I really like to use histograms. You will see pretty much the rest of this course, that's all you're going to be making is histograms and studying histograms. The stem and leaf, the very first number, so notice there's 15, 16. The first number is this first digit. The second number is the leaf. So I can kind of read these without even looking up here, 21, 23, 23, 26, 26. So you do repeat. You have to put a 0 for 30 and so on. Okay, and then once again, we can just have some basic line graphs. This is our scatter plot where we try to see some relationship with the data. And then once again, looking at dot plots. When we get to qualitative data, we typically like pie charts. Everybody likes pie charts because they're easy to make and they're easy to read, right? And you normally would put your percentages in here. We can have bar charts. Notice this is different from a histogram. A histogram, there's no space between here. So it's just one bar for each category. And we can even have stacked bar charts. So that's just a very quick overview of everything you're going to do this week. Again, you got to read the chapter, read through, I put in there some key terms that you need to understand. When you get working on the homework assignment, if there's any question that you cannot work, send it to me and I'll make a video. I'll continue to make videos as this course grows.